So, alright guys, so I'm going to be touching the moment of a force, alright? So, actually, I'm going to be solving this question. I'm going to break it down and make it very simpler, alright? But you wish that you want to know the deep down, like the craziest part, the hardest part of this topic. On my video, you'll be seeing my numbers there. You can message me. Our WhatsApp online class is going, both online and physical. If from distant places, you can join our WhatsApp online classes. Don't hesitate to message me on that number, and you will know that God is great after the classes is very rounded off before your exams. I am Eli Tuto, your regular one. Alright, so today we're going to be talking about moment of a force. First and foremost, you know what your moment is. The moment of a force or a moment of a body is what? Is a product of your what? Of your force and perpendicular distance. For instance, I am having a pivot here. This is a fulcrum. Then I have my meter rule placed on this fulcrum. Then I decided to hang a force here. Alright, so there is a distance it will take for we to move this force to this junction. This is a load, alright? You can classify it as your force if you like. So there is a distance with which it will take for us to move it. So that is why I am giving it a distance x, alright? So this is our CG, center of gravity, alright? So for the fulcrum, where it rotates, do you understand? So now, this distance and this is a force, like I said earlier, you can regard it as your load. So for me to take the moment of this whole side, the moment of this whole side becomes this force multiplied by the distance. The distance should not be coming from outside, it should be coming reading from the inside, that is coming from the side of the fulcrum. Very, very simple. That is, our moment is equal to force times perpendicular distance. No stress. Anyway, so that's that by the way. I told you I was going to brief the intro about this to get down to the solution of the questions. Now look at this question. Take a look at this question. It is not hard. Now they said a body of mass 120 grams placed at 10 centimeters on a uniform meter rule makes the rule settle horizontally on a fulcrum placed at 35 centimeter mark. Calculate the marks of the rule. Now, something about moment of a force, the shortcut to solve problems. You will look at that question you are having. Take a look at it. Are we to use a full meter rule or a half meter rule? So the question you have determines if you are to use a full length meter rule or a half meter rule. A full meter rule takes what? A measurement of 0 to 100 centimeter. Okay? While a half meter rule takes 0 to 50, it accommodates just 50 centimeter. Alright, so any question you have will determine whether you are using the half meter rule or the full meter rule. So, critically looking at this question, you look at this. What is the highest measurement in this question? The highest measurement there is 35 centimeter, which suffices that you are going to use the half length meter rule. But assuming you are having measurement that are above 50 centimeter, it suffices that what you are going to be using a full meter rule. Get the point. If you are having lengths that are below 50, then you are going to be using a what? A half meter rule, and a half meter rule is 50 centimeter. And looking at this, the total length that we have here is what? Is 35 centimeter. The total length we are having here, the measurement inside this question is 35 centimeter, which means you have to drag out your what? Your half meter rule. So don't forget your half meter rule is from what? Is 0 centimeter to what? 50 centimeter. We already know the meter rule we are using. So clearly, you know that half of this. Now, the second step is that take note of half of the meter rule you are using. Now, this is the meter rule we are using. We already know the kind of meter rule we are using. Okay? So, you have to note down the half of the meter rule you have already suggested to use according to the question. So, it is very clear that the half of this meter rule is 25 centimeters. So, take note of it. 25. I'm still going to clean this noting down. 25 centimeter. Half of this meter, I've shared it into half. So after you have done that, it will be easy for you to make your placement. And the third step is that whenever you want to, how do you locate the mass you are hanging or the force you are hanging on your fulcrum? How do you locate them, and where do you start from? Anything you want to hang, if they didn't specify, then you have to start from the zero, reading from the zero side. Okay, you have to start reading from what is 0 centimeter side. How does it goes? It follows that a body of mass 120 grams placed at 10 centimeter. Now they said it is placed at 10 centimeter. Now if you have to read off from the 0 centimeter, you will just assume that 10 centimeter should be around this side. Okay, you don't have time to be taking that ruler and be measuring. There's no time for that. So looking at it, you can know that from here to here should be your 10. It cannot pass this junction. So let's say this place should be our 10 centimeter. So it cannot pass that range. You just try to estimate it from the ruler. So from here to here should be like 10 centimeter. So read the question again. A body of mass 120 grams placed at 10 centimeter. So what is the body placed? 120 grams placed at 10 centimeter. Okay, on the uniform meter rule. So we have already targeted 10 centimeter on the meter rule. So from 0 to 10, this is it now. Alright, let's read further. Makes the 10 centimeter mark on the uniform meter rule makes the rule settle horizontally. It is actually going to settle horizontally on a fulcrum. What is the fulcrum? This fulcrum is what we also call a pivot junction. That thing that looks like a wood that you have in your laboratory where you place your ruler. That triangle, that's your fulcrum. So they mean that this ruler, after handling this mass, this ruler was placed on what? On a fulcrum at what? At 35 centimeter mark. Don't forget I said whatever measurement they are giving you, you have to read it off from the 0 centimeter. So looking at it, you can use your eyes to gauge it that okay, it's 35 centimeter mark. So let's read it from the 0. From the 0, okay, since this place is 25, you know that's why I said that you should share it into with the meter you are using that you already know you are using, you should share it into half and note it. So since you already know half of this place is 25, so and they said the fulcrum is placed at 35, so they are reading from 0. Since this is 25, we can just add small length here. So we can just assume that this place, since this 25, so 35 should pass it small. So this place should be our 35. This is our fulcrum here. So this 35 centimeter. Alright, so the fulcrum is placed at 35 centimeters. So we can now clean this guy away. Alright. So they now say calculate the max of the what? Of the meter rule. Are you with me now? They say calculate the mass, no max. Calculate the mass of the meter rule. How do we calculate the mass? So we don't know, they didn't specify, they just say calculate the mass. And we don't know the distance. So just put this hanging mass at any point here. Since they didn't specify, they just say to calculate the mass that is hanging here. So you can either put it here or here, anyone is fine. Alright. So now, as I said, you calculate the mass of this place. So what's the next thing you are going to consider? So the next thing you are going to consider, remember that moment is force times perpendicular distance. Force times perpendicular distance. Force times perpendicular distance. Like, you remember when they were proving it to you that this place is what? From your OKK textbook. This place is, let this place be your F1, this place be your F2. This is the clockwise direction, and this is the anti-clockwise direction. So if this one is F1, let this one be X1. If this one is F2, let this be X2. Okay? Alright, so clockwise direction is the working manner of the clock. The way clock works, that direction which clocks, the pointer of clocks follow, is what we call the clockwise direction. Then the backwardness of that working principle is anti-clockwise. So going by the second condition, is it the second? Yeah, the second condition of the parallel coplanar forces. It states that what? It states that clockwise moment is equal to anti-clockwise moment. So the sum of clockwise moment equals to anti-clockwise moment, which means that this is the clockwise side. The clockwise moment, what is moment? Moment is force times perpendicular distance. Force times perpendicular distance. Clockwise moment, sum of clockwise moments equals to anti-clockwise moment. F1, X1. Alright, so that is it. So we are going to apply the same thing here. So we can proceed further. Alright, so now let's proceed. Now this is our clockwise. and this is our anti-clockwise. Okay, this is our anti-clockwise. But we have not gotten our distance. Look at from here to here is 10. So if from here to here is 10 and from here to here is 35, the total length from here to here is 35. To get the remaining part of this one, you have to subtract this 10 from 35 to give you the remaining value here. So 30 minus 10 that you have here will give you the distance here. So this place is going to be 25 centimeter. Okay, so now if from here to here is 35 and from here to here is 50, what will be the distance here? So from here to here is 35, that will be 50 minus 35. So this one is going to be what? This 50 minus 35 is going to be 15 centimeter. Okay, so we have balanced the both side lengths now. So we can now further to calculate our mass of the metal. This is clockwise. So let's follow the rule. Sum of the clockwise moment, the anti-clockwise moment. Alright. So let's take the clockwise moment now. The clockwise moment says the mass here multiplied by the perpendicular distance here. That's m multiplied by 15 is equals to, let's take the clockwise and the moment of the anti-clockwise. 120 multiplied by 120 multiplied by 25. 120 multiplied by 25. Alright, so 5 here 3, 5 here 5. Okay, so we have 3m is equals to 120 into 5. Okay, 3 here 1, 3 here 60. I mean 3 in 12 is 4. Okay, 3 in 120 is 40. So we are left with m is equal to 40 into 5. Then our m is equal to what? 200 grams. So the value of m here is 200 grams. So that's option D. So to check if the answer is correct, just multiply this by this and multiply this by this. If what you are getting does not correlate, if they are not the same, then something is wrong somewhere. That is how to check the answer. If this video is clear, make sure you drop the comment in the comment section. Bye bye.